Hi everyone, welcome to my channel, Maths Made Easy with Terry in 10 minutes. So we're going to talk about three-dimensional components of vector. All right, in the previous video, we talked about two-dimensional component. I'm going to talk about three-dimensional component here. Actually, it's going to be a short video as well. But before I proceed, don't forget to like, share, and subscribe. If not, click the notification bell. I don't know what you're waiting for. Please do so that when I post new videos, you'll be the first person to know. All right, so in the previous video, we only considered vectors that lie in the x and y plane. So we talked about the unit vector I and j. Now, but in the three-dimensional vector, we're going to talk about a third directional vector or a third direction, which is perpendicular to both the x and the y. And we call this the z. And the unit vector for this is going to be called the k, all right? So I'm not going to just go so much into it because for this series, it's going to be more than the required knowledge. But what I'm just going to say is that here, instead of us having just I, J, K, I, and J, like what we had in two-dimensional, we're going to be having I, J, K. So we're going to be having three-dimensional here. And because I'm aware that students do take notes, I'm going to write down what I just said so that you can also have that as well. So previously, okay. So previously, so I'm talking about the previous video. We only considered vectors. So we only consider vectors that lie in the x and y plane. Okay, so we talked about the x plane and y plane. And we did that using a mutually perpendicular unit vector. So we did I and J, right? So we talked about this as well, okay? Now, but in order for us to do this, we have to consider vector in space. So we need a third direction. So you have to consider vectors in space. Okay, so we need a third direction. With an axis, okay? A third direction with an axis that is perpendicular to both. Okay, so we need a third direction that is perpendicular to both the x and y axis, and this is what we call the x-axis, z-axis. So this is provided or called by the z-axis. So here we're going to be talking about the z-axis. So in the previous one, we just talked about the x and y, but there's a third axis called the z-axis, okay? So we're going to have then, um, so we're going to have, so when you look at it then, therefore, we have the x, y, and what? Z axis. So this in a three dimension, you have three axis that then define, okay, this vector. So then they define three mutually perpendicular what? Direction. Okay, for the axis. So some people call it the right-hand rule. We'll talk about that later. So basically, which obey the right-hand rule. Okay, good. So let me see if I can diagrammatically show you this. So, and for this as well, for the unit vector, for the third axis, which is the Z, for the unit vector, we call it K, okay? So the unit vector for the Z component. So if you remember, the X was I, the Y was J, right? But for the Z, it's going to be K. Okay? So remember, I said remember, just a reminder. X was what? We called it I, and Y, we called it J, okay? But in this case, for the Z, it's going to be referred to as what? K. So, so we'll go back to that OP. Remember the last time we had OP? So let's say we had vector O and P, okay? And we've all agreed that we have the X and Y components. So we have the Y here, we have the X here, okay? So this is X and Y. And we then have a third component, which is the what? The Z. Okay? So the X component, okay? Remember we said is the A, the Y component, so this is the B, then the Z component is going to be the C, okay? So if you now, or if I put it this way, maybe if I write it this way, it will make sense. So you're gonna have, for this now, we can now drag it all the way up, okay? So you can see that we have a Z component here. Okay, and this is going to come down. So you see it follows the right-hand rule. Then we have this one. You see this one here. Then we have that. Goes all the way to the X component. Then we go all the way down there to the X. Bring it take that away a bit. Then bring it all the way. Okay, and you can then have this. So you have the Z, from the Z, you can have that. Okay, then you can also draw this as well. So if you go to the textbook, you will see this will be drawn more accurately, or I can clean this and try to make this, the X component, a little bit better. So you can have something like this. So the X components. So we can make this a little bit cleaner. Okay. So it's gonna come up a bit now. Okay, so we can now have this once come out a bit here. So it looks a bit cleaner now. Okay, so that is it. So we can now say this is the B here, the B component. This was the A component, and this was the C component for that. And as usual, that was the origin. Then you can see, I can call it the point L and P. So when you look at it, you see that for this simple vector OQ, okay, OP, sorry, we have about 3 components, the X component, the Y component, and the Z component. So therefore, we can now say OP now, okay, it's a combination of 3 components. So the A, which is the X component, plus the B, which is the what? The Y component, plus the C, which is the what? K component, all right? Then similarly, to find the R, we talked about R in the 2 components. So instead of it just be A squared, you know, the last video, I just said A squared plus B squared. But this time, you're just going to add what? C squared to it. So they have proof for this, but I'm not going to talk about the proof. All right. So if, for instance, we have, let's say we have an example now. If we're told, let me use black for this. So if we're told that PQ, vector PQ, has this component 4I plus 3J plus 2K, and you were told to find the magnitude of peak Q. Okay. So what you do is going to be equal to the square root of 4 squared plus 3 squared plus 2 squared, and that will give us what? Square root of 29. Or if you ask to put it in decimal, it's going to give us 5.385. Okay? And that is how you find that. So you just see that the third dimension is just the concept. The only difference here is that we are adding the third component, which is the Z axis, and which is provided by the unit vector K. And also similarly to R, you just need to just add K, the component K, to the formula, and you will get that. All right. So don't worry, we're going to talk about this more down the series, and we're going to solve more questions on this. So I just thought it's important for me to mention it here before I now proceed down the line. All right. So thank you very much. If you have any question, please feel free to contact me, and I'll get back to you as soon as I can. All right. So I'm going to see you in the next video where we're going to talk about addition and subtraction of what? Vectors. Okay. See you soon.